In the unending, silent theater of the cosmos, where darkness is the stage and light is the fleeting player, there exists a quiet so profound it defies human comprehension. It is a silence stitched together by the threads of gravity and time, a velvet cloak stretching across voids so vast they could swallow 1,000 civilizations without a whisper. In this grand emptiness, light travels not as a herald, but as a memory, an ancient ghost carrying tales from a past we can never touch. Imagine, if you will, a single point of this light, a photon born in the heart of a star that died before our planet was even formed. It has journeyed across unfathomable distances, past sleeping nebulae and slumbering giants, its path bent by the invisible weight of dark matter, its purpose simply to travel. And after millions, or even billions of years, it arrives here, at our cosmic shore, a single, weary messenger from a forgotten kingdom. We look up and see it as a star, but we are truly looking into a tomb, a beautiful, glittering epitaph for a sun long since extinguished. Across the expanse, there are structures that defy our sense of scale and time. Consider the galaxy known as Dragonfly 44. It is a phantom, a whisper in the cosmic dark. To our telescopes, it appears as a faint, scattered collection of stars, a city of ghosts barely holding itself together. It is as massive as our own Milky Way, yet it shines with only 1% of its light. It is a dark twin, a shadow galaxy filled with ancient, dying stars and an overwhelming abundance of something else, something unseen that gives it weight and form. This colossal, silent entity drifts through the Coma Cluster, a ghost ship on a sea of black, its crew of stars long past their fiery youth. It does not rage with the brilliant blue light of stellar nurseries, it does not swirl with the vibrant pinks of ionized hydrogen. It simply is. A quiet testament to an age of the universe that has passed, a relic of cosmic twilight. It poses a question that echoes in the silent halls of space-time. What does it mean for something so vast, so massive, to be so quiet? What forgotten lullaby does a galaxy sing when its stars have all grown old? We seek noise, we seek light, we seek the vibrant signs of life and creation. But the universe, in its oldest and most profound manifestations, speaks in silence. It is in this immense, patient quiet that the deepest truths reside. Tonight, we will not chase the supernovas or the quasars. We will not listen for the roar of cosmic engines. Instead, we will lean in close and listen to the silence. We will learn the language of gravity's slow embrace, of light's patient journey, of a universe that finds its ultimate expression not in a bang, but in a breath held for eternity. Are you ready to listen to the quiet? Are you ready to explore the soothing, silent truths that cradle the cosmos in their gentle, invisible arms? Now, let's begin. Music. Every galaxy, including our own Milky Way, is a living poem written in the language of gravity. It is not a static object, a mere collection of stars pinned to the fabric of space. It is a dynamic, breathing entity, a celestial organism whose lifespan is measured in eons. Its arms, those beautiful, swirling appendages of light and dust, are not solid structures. They are illusions of density, cosmic traffic jams where the flow of stars and gas slows, compresses, and ignites. Think of them as waves, not on an ocean of water, but on an ocean of spacetime itself. These are density waves, ripples of gravitational potential that sweep through the galactic disk at a steady, patient pace. As they pass, they gather the interstellar medium, the thin, cold hydrogen gas that drifts between the stars, and squeeze it. This gentle, persistent compression is the catalyst for creation. Within these swirling arms, the squeezed gas clouds collapse under their own weight, fragmenting into smaller and smaller clumps. The temperature and pressure at their cores begin to rise, climbing over millions of years until they reach the critical threshold for nuclear fusion. A star is born. This is the galaxy's breath. A slow, rhythmic inhalation of cold gas into its spiral arms, and a brilliant exhalation of light and life in the form of new stars. The most massive of these newborns burn a brilliant, fierce blue, living short, spectacular lives before they die in supernova explosions. These deaths are not endings, they are a continuation of the cycle. They enrich the interstellar medium with heavy elements, carbon, oxygen, iron, forged in their nuclear hearts. This enriched material is then swept up by the next density wave, becoming the building blocks for a new generation of stars, and eventually, for planets, and for life itself. Our Sun, our Earth, and our very bodies are made of this stardust, the recycled ashes of stars that lived and died in the Milky Way spiral arms billions of years ago. We are, in the most literal sense, the children of this galactic breath. The entire structure, this pinwheel of 100 billion suns, is engaged in a majestic rotation. But it does not spin like a solid disk. The stars closer to the center complete their orbits much faster than those on the periphery. Our own solar system, located about 2/3 of the way out from the galactic core, travels at a staggering 220 kilometers per second. Even at this incredible speed, it takes us approximately 230 million years to complete one full orbit around the Milky Way. This is a single galactic year. The last time our solar system was in this same position, dinosaurs were just beginning to walk the Earth. The time before that, the planet was a barren rock, recovering from a mass extinction that wiped out most of its life. The entire history of humanity, from the first hominids to the present day, has taken place during a tiny fraction of this single, celestial lap. This immense, slow turning is a cosmic lullaby. It is a motion so vast and so patient that it renders our own frantic lives into a state of profound stillness. We are passengers on this grand, celestial carousel, held in place by a gentle, invisible force, carried through the silent darkness on a river of stars. The galaxy does not hurry. It does not rush. It simply turns, breathing in dust and breathing out light, a timeless, self-sustaining engine of creation, cradling us in its slowly spinning arms as it has for billions of years, a silent, ever-present guardian in the cosmic night. Let us now zoom in, from the sweeping arms of the galaxy to the individual points of light that give it form. Each star is a universe unto itself, a sphere of incandescent plasma locked in a delicate, lifelong battle between two fundamental forces. Outward, there is the relentless pressure of nuclear fusion, the energy released by the violent fusing of atoms in its core. This is the star's fire, its will to expand, to radiate, to fill the void with its light and heat. Pushing inward is the crushing, inescapable force of its own gravity, the weight of its own immense mass pulling every particle toward the center. This is the star's anchor, its desire for collapse, for silence, for a final, dense point of oblivion. A star's entire life is spent maintaining the perfect equilibrium between these two titanic forces. For a star like our Sun, this balance is held for billions of years in a state of serene stability. Deep within its core, where temperatures reach 15 million degrees Celsius, hydrogen atoms are fused into helium. Every second, the Sun converts about 600 million tons of hydrogen into 596 million tons of helium. The missing 4 million tons are not lost, they are transformed directly into energy, according to Einstein's famous equation, E equals mc squared. This is the source of all the light and warmth that bathes our planet. It is not a chaotic, uncontrolled explosion. It is a steady, self-regulating nuclear reaction, a celestial heartbeat that has pulsed with unwavering rhythm for 46 billion years. This process is the universe's most profound alchemy. It is the transmutation of the simplest element into the more complex, the forging of reality itself. The light produced in the Sun's core does not escape immediately. A single photon, a particle of light, begins a journey that can take hundreds of thousands of years. It is born in the inferno of the core and immediately collides with a dense particle, being absorbed and then re-emitted in a random direction. It stumbles through the radiative zone, a celestial drunkard bouncing from atom to atom, its path a chaotic zigzag. For millennia, it is trapped within the star, its energy slowly making its way outward. Finally, it reaches the convective zone, the outer layer of the Sun, where it is carried to the surface by vast, rolling currents of hot plasma, like a passenger on a cosmic escalator. Only then, after an immense journey through the star's interior, is it released into the void of space. The sunlight that warms your face on a summer day began its life perhaps before human civilization even existed. It then travels for a mere 8 minutes across the 93 million miles to Earth, a final, short sprint after an epic, internal marathon. This patient, ancient light is a physical connection to the heart of our star. It carries the story of its creation, its long imprisonment, and its final liberation. And this story is repeated 100 billion times in our galaxy alone. The night sky is not a collection of distant fires, it is a museum of ancient light, a tapestry woven with photons that have traveled for years, centuries, or millennia. Some of the stars you see tonight may have already died, their light only now reaching us, a final, beautiful farewell from across the abyss. Each one is a testament to that perfect, serene balance between expansion and collapse, a quiet, burning lamp held steady against the infinite dark. But the visible light, the stars, the gas, the dust, all of this is but a fragile wisp, a mere 5% of the universe's total mass and energy. The rest is hidden, a cosmic dark sector that governs the universe on its grandest scales. The most significant component of this hidden reality is dark matter. It is the galaxy's skeleton, its silent, invisible scaffolding. We cannot see it. It does not emit, reflect, or absorb light. It interacts with our world only through the subtle, persistent tug of its gravity. Yet, without it, galaxies as we know them would not exist. When we observe the rotation of our galaxy, we find a profound anomaly. The stars on the outer edges are moving far too quickly. According to our understanding of gravity, based on the visible matter we can see, these stars should be flung off into intergalactic space, like children letting go of a rapidly spinning carousel. The galaxy should tear itself apart. But it doesn't. It remains whole, its spiral structure stable and coherent. There must be something else there, an enormous amount of unseen mass, providing the extra gravitational glue needed to hold everything together. This is dark matter. It forms a vast, spherical halo, extending far beyond the visible disk of the galaxy, enveloping our entire stellar city in its gentle, unseen embrace. It is the galaxy's guardian, its quiet shepherd. While the stars are born, live, and die in a brilliant, chaotic dance, the dark matter halo remains largely unchanged, a steady, foundational presence. It does not participate in the fiery drama of stellar evolution. It simply provides the stage, the gravitational arena in which the cosmic play unfolds. Its presence is like the silent, deep current of an ocean, which guides the shimmering waves on the surface. We feel its effects everywhere, yet its nature remains one of the greatest mysteries in all of science. We do not know what it is made of. It could be a new type of subatomic particle, something outside our standard model of particle physics, a WIMP, weakly interacting massive particle, or an axion, ghost-like particles that pass through us, through the Earth, through everything, as if we were not even here. This silent, pervasive substance is not a void. It is a presence. It is the cosmic bedrock. During the early universe, it was the gravity of dark matter that acted as the seed for all structure. Clumps of dark matter were the first things to form, creating gravitational wells, or divots, in the fabric of space-time. The ordinary matter, the hydrogen and helium gas forged in the Big Bang, was then drawn into these wells, slowly accumulating into the vast pools of material that would eventually ignite to become the first galaxies. Dark matter, therefore, is not just the glue that holds galaxies together today, it is the architect that designed them in the first place. It is the unseen hand that sculpted the cosmic web, the grand, filamentary structure of the universe. It is a quiet, foundational truth, a reminder that what we see is only a fraction of what is real. To drift off to sleep contemplating dark matter is to accept the profound and soothing reality that we are held and supported by forces we cannot see and do not yet understand. It is to trust in the unseen architecture of the cosmos, to feel the gentle, persistent gravity of a substance that asks for nothing, shines with no light, but silently, patiently, holds our entire world together in the vast, cold dark. The universe, for all its silent majesty, is not a place of eternal stasis. It is a dynamic, evolving tapestry, and its primary method of growth is through consumption. Galaxies are cannibals. They grow by merging with, and devouring, their smaller neighbors. This process is not a violent, instantaneous collision, but a slow, graceful, and ultimately transformative dance that unfolds over hundreds of millions of years. Our own Milky Way is a seasoned predator. Within its vast dark matter halo, we can find the shredded remains of numerous dwarf galaxies that it has consumed over its long lifetime. These are visible as stellar streams, great, arcing rivers of stars that trace the final, doomed orbits of these captured galaxies before their stars were scattered and assimilated into our own. The Sagittarius Stream, for example, wraps around the Milky Way like a celestial ribbon, a ghostly trail marking the slow death of a dwarf galaxy that is even now being torn apart by our galaxy's immense tidal forces. This is cosmic recycling on the grandest scale. The stars and gas from these smaller galaxies are not destroyed, they are incorporated, adding their mass and momentum to our own, enriching its diversity and fueling future generations of star formation. This process is fundamental to the story of our existence. But an even grander dance is on the horizon. Our nearest large galactic neighbor, the Andromeda Galaxy, is currently hurtling towards us at a speed of over 110 kilometers per second. While this sounds cataclysmic, the vast distances involved mean that this collision will not begin for another 4.5 billion years. When it does, it will not be a crash of stars. The space between stars is so immense that direct collisions will be exceptionally rare. If you were to watch from a safe distance, you would not see explosions. Instead, you would witness a breathtaking spectacle of gravitational artistry. The two great spiral galaxies, each a swirling pinwheel of hundreds of billions of suns, will first pass through each other. Their vast halos of dark matter will interact first, creating a drag that slows them down and binds them together in a gravitational embrace from which there is no escape. Over the next few billion years, they will fall back together, their shapes distorting under the immense tidal forces. Great plumes of stars and gas will be flung out into intergalactic space, forming long, glowing tidal tails. The two galactic disks will be twisted and warped, their elegant spiral structures completely destroyed. The interstellar gas within both galaxies will be violently compressed, triggering a colossal burst of star formation, a starburst that will set the merging galaxies alight with the brilliant blue fire of millions of new, massive stars. The sky of any future Earth would be a spectacle beyond imagination, a swirling, chaotic canvas of new constellations and nebulae. Eventually, after several passes, the two galaxies will merge completely. Their central supermassive black holes will spiral towards each other, finally combining in a cataclysmic event that will send gravitational waves shuddering across the fabric of space-time. The chaotic starburst will subside, the gas will be used up or expelled, and the new, larger galaxy will settle down. The result will not be a spiral, but a vast, spheroidal entity known as an elliptical galaxy. It will be a city of older, redder stars, a quieter, more mature cosmic metropolis. This future entity has already been named Milkomeda. The thought of this grand, slow-motion merger is not a cause for alarm, but for a sense of profound, long-term perspective. It is the universe's way of building, of creating new and grander structures from the old. It is a dance of gravity, a story of union, and a promise that even on the most cosmic of scales, the universe is not static, but is forever flowing, changing, and becoming something new. It is a soothing reminder that even the most seemingly destructive events are, from a cosmic perspective, acts of creation. At the very heart of this galactic dance, at the center of the Milky Way and nearly every other large galaxy, lies a point of ultimate gravity and finality, a supermassive black hole. Our galaxy's central engine is named Sagittarius A, a celestial monster with the mass of 4 million suns, all compressed into a region smaller than the orbit of Mercury. This entity is not a cosmic vacuum cleaner, aggressively sucking in everything around it. Its direct gravitational influence is only dominant in its immediate vicinity. From our distant perch, 26,000 light-years away, its pull is no different from that of 4 million stars clustered together. Yet, it is the galaxy's anchor, the still point around which the entire swirling disk of our star system revolves. It is the quiet, brooding heart of the Milky Way. We cannot see the black hole itself, for its gravity is so intense that not even light can escape its event horizon, the point of no return. What we can see, however, is the maelstrom of matter that has been captured by its gravity. Gas, dust, and the occasional unfortunate star are drawn into a swirling, incandescent structure called an accretion disk. As this material spirals inward, it is accelerated to near the speed of light and heated to millions of degrees by friction and compression. It glows with an intensity that can outshine all the stars in the galaxy combined. This is the phenomenon of a quasar, or an active galactic nucleus. Our own Sagittarius A is currently in a state of slumber. It is a quiet giant, feeding only on a thin trickle of interstellar gas. Its accretion disk is faint, a mere whisper of its potential power. But it is not dead. Occasionally, a gas cloud or a star wanders too close. We have witnessed, with our telescopes, the final moments of such encounters. A star, drawn in by the immense tidal forces, is stretched and pulled apart, a process gruesomely termed spaghettification. It is shredded into a long stream of hot gas, which then flows into the accretion disk, causing the black hole to flare up, to briefly awaken from its slumber with a burst of X-rays and radiation before settling back into its quiet state. This central heart, even in its quiescence, plays a crucial role in regulating the life of the entire galaxy. The intense energy and radiation blasting out from the accretion disk, even a faint one, can heat up the surrounding gas, preventing it from cooling and collapsing to form new stars. Powerful jets of plasma, launched from the poles of the black hole by twisted magnetic fields, can travel for thousands of light-years, clearing out vast regions of the galactic core. This process, known as feedback, creates a delicate balance. If the black hole feeds too much, it becomes active and shuts off star formation. As the fuel source is depleted, the black hole quiets down, allowing the gas to cool and star formation to resume. It is a cosmic thermostat, a self-regulating mechanism that ensures the galaxy does not burn through its fuel for new stars too quickly. It is a force of both creation and destruction, a paradoxical entity that sits at the heart of it all. To contemplate this sleeping giant is to embrace the universe's profound duality. It is to understand that the point of greatest collapse is also a source of regulatory power, that the darkest object in the universe is responsible for some of its most brilliant light. It is the galaxy's calm, patient, gravitational soul, a silent reminder that at the center of the most chaotic motion, there can be a point of profound and powerful stillness. Now, let us zoom out once more, far beyond the confines of our own Milky beyond our local group of galaxies, into the truly incomprehensible scales of the universe. Here, we discover that galaxies are not scattered randomly like dust motes in a sunbeam. They are organized. They are connected. They are part of a structure so vast and so intricate it is known as the cosmic web. This is the largest scale structure in the entire universe, a celestial network of unimaginable proportions. On this scale, the primary architect is not ordinary matter, but the silent, pervasive influence of dark matter. Computer simulations of the early universe show that as space expanded, the gravity of dark matter pulled it into a vast, interconnected, web-like pattern. It formed dense, compact knots at the intersections, long, thin filaments connecting them, and vast, nearly empty regions in between, known as voids. Ordinary matter, the gas that would form stars and galaxies, was then drawn by gravity into this pre-existing dark matter scaffold. The galaxies, therefore, are like glowing cities that have been built along the invisible highways and at the major intersections of this cosmic superstructure. The knots of the web are the great galaxy clusters, sprawling metropolises containing thousands of individual galaxies, all bound together by their mutual gravity and swimming in a sea of superheated gas. The local group, which includes the Milky Way and Andromeda, is located on the outskirts of one such massive structure, the Virgo supercluster. Connecting these clusters are the filaments, enormous bridges of dark matter and tenuous gas that can stretch for hundreds of millions of light-years. Galaxies are strung along these filaments like pearls on a string. These filaments are not just static structures, they are cosmic rivers. Gas flows along them from the voids, channeling matter into the clusters, providing the raw fuel for the galaxies within them to continue their cycles of star formation and growth. Our own galaxy is constantly being fed by a slow, gentle rain of hydrogen gas, trickling down these cosmic filaments. The voids, in contrast, are the great cosmic deserts. They are immense, underdense regions, some hundreds of millions of light-years across, where there are very few, if any, galaxies. They are the quiet, empty spaces that give the cosmic web its structure and definition. To visualize this is to see the universe not as a collection of isolated islands, but as a single, interconnected organism. It is a cosmic brain, with the galaxy clusters as its neurons and the filaments as the synapses connecting them. Information, in the form of matter and gravity, flows along these pathways, coordinating the evolution of the universe on its largest scales. This revelation brings a sense of profound belonging. Our galaxy is not alone, adrift in an infinite void. It is a part of a community, a member of a grand, cosmic society, linked to countless others by invisible threads of gravity and matter. We are a node in a network that spans the entire observable universe. This understanding is deeply soothing. It replaces the idea of cosmic loneliness with one of universal connection. It suggests that the same fundamental patterns, networks, flows, connections, repeat themselves at every scale, from the neurons in our own brains to the arrangement of galaxies across billions of light-years. We are embedded in a structure of sublime and beautiful order, a web of existence that holds everything, everywhere, together. Let us now travel not in space, but in time, back to the very dawn of the cosmos, to listen to the universe's first and most enduring lullaby. We cannot see the Big Bang itself. The universe in its first few 100,000 years was an opaque, incandescent fog of plasma, a place where light was trapped, unable to travel freely. But we can see the moment the universe finally cooled enough for that light to be set free. This moment, which occurred about 380,000 years after the Big Bang, is called recombination. It was when electrons and protons first combined to form neutral hydrogen atoms, clearing the cosmic fog and allowing the photons of light to begin their epic journey across space-time. This first light is still with us today. It is all around us, filling every cubic centimeter of space. It is the cosmic microwave background, or the CMB. As the universe has expanded over the past 138 billion years, the fabric of space itself has stretched, and this ancient light has been stretched along with it. Its wavelength has been redshifted from the high-energy gamma rays of the early universe all the way down to the low-energy microwave part of the electromagnetic spectrum. It is now incredibly cold, just 27 Kelvin above absolute zero. If our eyes could see in microwaves, the entire night sky would glow with a faint, almost perfectly uniform light. This is the afterglow of creation, the fading ember of the cosmic dawn. When you tune an old analog television to a dead channel, about 1% of the static, the snow on the screen, is interference from the cosmic microwave background. You are, in that moment, seeing the residual light from the birth of the universe. This is the oldest photograph possible, a baby picture of the cosmos when it was just an infant. And it is a picture of almost perfect uniformity. The temperature of the CMB is the same in every direction we look, to an astonishing degree of precision. This implies that the early universe was in a state of incredible equilibrium, a smooth, homogeneous soup. But it is the imperfections, the tiny, almost imperceptible variations in this temperature, that tell the most profound story. These variations, which differ by only 1 part in 100,000, are the seeds of all structure in the universe today. The slightly denser, slightly cooler spots in the CMB map were the regions where gravity had a slightly stronger pull. These were the primordial seeds that, over billions of years, would grow into the vast filaments and clusters of the cosmic web, the galaxies, the stars, the planets, and ultimately, us. We are the direct descendants of these minuscule, quantum fluctuations in the fabric of the newborn universe. The CMB is the ultimate cosmic lullaby. It is a constant, gentle hum that underlies all of reality. It is the memory of a time when everything was connected, a time before stars and galaxies, when the entire universe was a single, unified, glowing entity. It is a profound reminder of our shared origin. Every atom in your body, every star in the sky, every galaxy in the cosmos, can trace its history back to that hot, dense state, and to the moment this ancient light was set free. To fall asleep while contemplating the cosmic microwave background is to feel the faint, residual warmth of creation on your skin. It is to be swaddled in the oldest light in the universe, a silent, ubiquitous presence that connects us directly to the very beginning of time itself. While most of creation is bound together in the great cosmic web, the universe is also a place of solitude, of journeys undertaken in the vast and silent darkness between the galaxies. Not all stars remain in the gravitational embrace of their birthplaces. Occasionally, through chaotic gravitational interactions within a dense star cluster or a close encounter with a galaxy's central black hole, a star can be ejected with such tremendous velocity that it escapes the galaxy's gravitational pull entirely. These are the hypervelocity stars, the lonely travelers of the cosmos. They are shot out of their home galaxies like celestial cannonballs, destined to travel forever through the immense, empty expanse of intergalactic space. Their journey is one of sublime and absolute solitude. For millions, or even billions of years, they will travel through a darkness so complete that the nearest star may be thousands of light-years away. The light from their parent galaxy will slowly fade behind them, eventually becoming just another faint smudge in their sky, indistinguishable from any other. If such a star had planets, any life on them would witness a sky slowly being emptied of its stars, until only the single, lonely sun remained against a backdrop of near-perfect blackness, punctuated only by the faint, distant glow of other galaxies. This journey is not necessarily a tragic one. It is a testament to the universe's ability to spread its seeds. These rogue stars carry with them the heavy elements forged in their parent galaxy, seeding the barren intergalactic medium with the building blocks of future creation. In the distant future, this material might collect and form new, isolated dwarf galaxies in the heart of the great voids. There are also rogue planets, worlds that have been ejected from their solar systems during the chaotic early stages of their formation. These dark, cold worlds travel through the galaxy untethered to any star. They are not necessarily dead. A large, gas giant planet with a thick atmosphere of hydrogen could remain warm in its core for trillions of years due to internal heat from radioactive decay and gravitational contraction. A rocky, Earth-like planet, if it had a thick atmosphere and a geologically active core, could potentially maintain liquid water oceans on its surface or beneath a thick sheet of ice, warmed not by a sun, but by the heat of its own heart. Life could potentially exist on such a world, a biosphere adapted to eternal darkness, powered by chemosynthesis from volcanic vents. Our galaxy could be teeming with these dark, wandering worlds, a hidden population of lonely travelers. They are silent, unseen, and represent a form of cosmic persistence that defies our sun-centric view of life. The existence of these lonely travelers, both stars and planets, paints a picture of the universe that is both grand and poignant. It speaks of dispersal, of endurance, and of the possibility of existence in the most extreme and isolated of environments. It is a soothing thought, in its own way. It reminds us that even when cast out, even when utterly alone in the greatest of voids, an object can still carry within it the legacy of its creation and the potential for a future we cannot yet imagine. It is a cosmic promise that even in the deepest silence and the most profound darkness, the journey continues. We have traveled from the breathing arms of our galaxy to its silent, supermassive heart. We have witnessed the grand, creative dance of galactic mergers and traced the invisible scaffolding of dark matter that holds it all together. We have zoomed out to the interconnected cosmic web and journeyed back in time to the faint, warm echo of creation itself. We have considered the lonely arcs, the rogue stars and planets sailing the empty oceans between the galaxies. And now, we return. We return to our small, blue world, a speck of dust in the grand, celestial scheme, yet a place of unique and precious complexity. The mystery of the silent, ghost galaxy, Dragonfly 44, is not a story of death, but of a different kind of life. It is a galaxy that used up its gas early, that completed its star-forming frenzy billions of years ago, and has now settled into a long, quiet retirement. It is a portrait of cosmic maturity, a glimpse into a possible, distant future for our own Milky Way, when its breath has slowed, its stellar nurseries have gone dark, and it floats in a state of serene, ancient grace. The universe, in its grandest narrative, is a story of transformation from a hot, dense, loud beginning to a cold, sparse, and silent future. The silence we perceive in space is not an absence, it is a destination. It is the peace that comes after the fire of creation has subsided. The soothing truths of the cosmos are not found in the denial of its violence or chaos, but in the understanding of the immense timescales over which that chaos resolves into a new and profound order. The merger of galaxies is not destruction, but union. The death of a star is not an end, but the scattering of seeds for new life. The dark matter we cannot see is not a void, but a gentle, steadying hand. The central black hole is not a monster, but a patient, regulating heart. And the silence of intergalactic space is not empty, but filled with the oldest light, the quietest travelers, and the promise of connection across the cosmic web. We are a brief, glorious, and complex flowering of consciousness in a universe that is mostly silent, mostly dark, and mostly empty. But we are not separate from that silence. We are born of it. The atoms in our bodies were forged in the hearts of stars that are now quiet. The gravity that holds us to this earth is a faint echo of the same force that binds galaxies together. The light by which we see is a traveler from a distant, nuclear fire. We are the universe's way of knowing itself, a fleeting moment in which the cosmos can reflect upon its own majestic, silent, and beautiful existence. The grand rhythm of the cosmos, the slow turn of the galaxy, the patient journey of light, the eons-long dance of gravity, is the ultimate lullaby. It is a rhythm of such immense scale that it invites us to let go of our own small, hurried pace, and to feel ourselves as part of this vast, eternal, and deeply peaceful process. What would you have done if you could witness it? If you could float in the void and watch, over 1 billion years, as two galaxies swirl together in a silent ballet of light and gravity, their chaos slowly settling into a new, single, glowing form? You would do nothing. You would simply be. You would watch, and in that silent, patient observation, you would understand. You would feel the profound, soothing truth that you are a part of it all. And you would finally, truly, be at peace.